Okay, so get ready, because today we're going deep on quantum teleportation. And I think everyone's probably familiar with like the Star Trek version,
Mhm.
beam me up, Scotty, that sort of thing. But what we're actually talking about is something much more complex. It's the transfer of quantum states,
Yeah.
not like physical objects.
Yeah, that's right. It's not about, moving atoms around. It's more about moving information. The essence of a particle, its quantum state, can be transferred instantly across vast distances.
And that's where I think it starts to get really interesting, right?
Yeah.
Because we're talking about quantum entanglement.
Exactly. Two particles intrinsically linked. You manipulate one and the other reacts instantaneously no matter how far apart they are. It's this, spooky action at a distance that Einstein talked about. And that's what makes quantum teleportation possible.
So how does it actually work? Let's try and break it down a little bit. Imagine we have these two entangled particles. We'll call them Alice and Bob. Alice is here on Earth, and Bob is on a satellite thousands of kilometers away.
Right. Okay, so then we introduce a third particle. We'll call her Carol. And Carol is carrying the quantum state that we want to teleport. We make Carol interact with Alice, and then we measure their combined state.
And that measurement instantly affects Bob's state up on the satellite, even though Bob and Carol have never interacted directly.
Yeah, it's like Carol's information is teleported to Bob, somehow bypassing any kind of physical connection. But there's a catch. Bob's state isn't an exact copy of Carol's. It needs a bit of an adjustment based on that initial measurement we did.
So we have to send those measurement results up to Bob. Not through any quantum trickery this time, just through normal means, like radio waves.
Right, and that information travels at the speed of light. But the teleportation of the quantum state itself, that seems to happen instantaneously.
And this isn't just theoretical, is it? I mean, scientists have actually achieved some pretty remarkable things.
Oh, absolutely. In 2022, researchers in China used a satellite called Mischius to teleport quantum states over 1,200 kilometers.
That's incredible, 1,200 kilometers. What about teleporting quantum states here on Earth?
Well, researchers at Delft University of Technology in the Netherlands, they achieved a 90% accuracy rate. They teleported quantum states between two nodes in a network just here on Earth. They use these things called nitrogen vacancy centers in diamonds to create and store these quantum bits or qubits.
90%, that's pretty impressive. So that's stopping us from getting to 100%. What are the challenges?
Noise. Noise is the big problem. Any environmental disturbance can disrupt that delicate entanglement and cause errors.
So things like temperature fluctuations, electromagnetic interference vibrations, all that can mess things up.
Exactly, but here's where it gets really interesting. Sometimes certain types of noise can actually enhance quantum teleportation.
Wave noise can be good. How does that even work?
Well, it comes down to this concept called multipartite hybrid entanglement. So instead of entangling just two particles, you entangle multiple particles and across different properties.
So instead of just two photons entangled by their polarization, maybe you'd entangle three photons by their polarization and their frequency.
Exactly. And by using this multipartite hybrid entanglement, researchers have achieved near-perfect teleportation fidelity, even with noise present.
So it's almost like noise-canceling headphones, but for quantum information. Instead of canceling out the noise, you're using it to make the teleportation stronger.
It's a good analogy, but instead of sound waves, we're dealing with a much more delicate world of quantum states.
So we've gone from beam me up, Scotty, to, manipulating photons and using noise to our advantage in this world of quantum teleportation. This isn't science fiction anymore.
No, it's very real, and it's a rapidly evolving field with some really profound implications. So now that we've sort of got the basics down, I think it's interesting to look at how quantum teleportation could really change things in the world. One of the big ones is cybersecurity.
Yeah, that's a huge one these days, right? I mean, it feels like our data is always at risk. You see all these hacks and data breaches in the news constantly. So how could quantum teleportation actually help with that?
Well, imagine a quantum internet. Instead of using bits, it uses those quantum bits, those qubits we talked about before, the ones that can exist in multiple states at the same time.
And because of entanglement, if someone tried to eavesdrop on that communication, it would immediately change the state of the qubits. So both the sender and the receiver would know that something was up.
Exactly. It'd be like having this unbreakable seal on your data. Hacking as we know it would be impossible. That's the whole idea behind quantum cryptography.
Wow. No more worrying about passwords or credit card fraud or any of that stuff. That sounds almost too good to be true.
Well, we're not quite there yet, but there are organizations like the EU Quantum Internet Alliance. They're putting a lot of resources into building these continent-wide quantum communication networks. Their goal is to have a working quantum internet connecting major cities across Europe by 2030.
That's pretty ambitious. But cybersecurity isn't the only place where this could have a big impact, is it? What about quantum computing? I've heard that term thrown around, but I'm still not sure I totally understand what it is or how it works.
Okay, so basically quantum computers are like the next generation of computers. They're way more powerful than the ones we use today. They actually use the principles of quantum mechanics to solve problems that are just impossible for even the most powerful regular computers.
So problems like drug discovery or material science or complex financial modeling, things that would take normal computers years, maybe even centuries to figure out.
Exactly, and that's where teleportation comes in. One of the big challenges with quantum computing is scalability. Like, how do you actually build a quantum computer with enough qubits to handle these really complex problems?
Right, and you can use entanglement and teleportation to do that. Instead of relying on physical wires, which can introduce all that noise and errors, you can just teleport those quantum states between processors.
That's the idea. You could create this vast network of quantum computing power all linked together. There was a study from the University of Chicago where they actually did this. They teleported quantum states between two processors using entangled photons. It's pretty groundbreaking. It could really pave the way for building these modular quantum computers that can just keep growing in size and power.
So we're talking about a future where quantum computers powered by teleportation could help us design new life-saving drugs and create amazing new materials. Maybe even solve some of the biggest problems facing the world.
That's the potential, for sure. We're still in the early stages, but the progress is incredible.
But it goes beyond just those practical applications like cybersecurity and computing, right? Quantum teleportation is also giving us a deeper understanding of the universe itself.
Oh, absolutely. Researchers are looking into how it could help us understand some of the biggest mysteries in physics. Things like the nature of space and time, even the behavior of black holes.
Black holes. Wow, I did not expect to be talking about black holes today. So how does teleportation fit into all of that?
Well, one of the most mind-boggling questions in physics is the information paradox. What happens to information that falls into a black hole? Does it just disappear, which would violate the laws of quantum mechanics, or is it somehow preserved?
I'm guessing quantum entanglement and teleportation might have some answers there?
Right. Some physicists believe that information that falls into a black hole could become entangled with particles outside the black hole. If we could figure out how to manipulate that entanglement, we might be able to teleport information out of a black hole and maybe solve that paradox.
This is getting pretty deep into theoretical physics now, but it's amazing to think that quantum teleportation could help us unlock the secrets of the universe.
It really is, and there's still so much more to discover. One really interesting area is the potential for quantum teleportation to completely change how we transmit energy.
Wait, are we talking about beaming energy around like they do in Star Trek? No more power lines, no more batteries, just pure energy zapping across space.
Well, it's not quite that sci-fi yet, at least not yet. But some early research suggests it might actually be possible to teleport energy states under very specific conditions.
So instead of sending electrons through wires, we can maybe teleport the energy itself.
Exactly. Imagine transmitting solar energy collected in space directly to Earth, or wireless charging that works instantly over any distance.
That would be a game changer, for sure, especially for sustainability and fighting climate change.
Yeah, it would be huge. It's still early days, and there are a lot of challenges to overcome. But the theoretical foundation is there, and researchers are actively working on it.
It's incredible to think we've gone from science fiction to real-world applications in such a short amount of time.
It really speaks to the power of human curiosity and scientific exploration. We've gone from barely understanding quantum mechanics to actually harnessing its power to teleport information and maybe even energy. It's an amazing journey, and it's really only just beginning. Who knows what incredible discoveries and applications are waiting for us in the future.
It's definitely exciting and maybe a little bit scary to think about all the possibilities. We've gone from beaming up Scotty to pondering the fate of the universe, all thanks to this mind-boggling world of quantum teleportation. I think that's a good place to leave it for now. I'm sure our listeners have a lot to think about. Thanks for joining us on this deep dive into quantum teleportation. So where do we go from here? What's next for quantum teleportation?
Well, I think on the practical side, one of the big things is improving the fidelity and reliability of the teleportation itself. We need to find better ways to deal with noise and decoherence, those environmental factors that can mess things up. And then, of course, we need to build the infrastructure for these large-scale quantum networks.
Right, that makes sense. What about the more theoretical side? Are there any big unanswered questions that researchers are still grappling with?
Oh, absolutely. I mean, there's still so much we don't know about the fundamental nature of quantum entanglement. Like, what does it really tell us about how the universe works? Exploring those questions could lead to some completely new discoveries, things we can't even imagine right now.
It's pretty mind-blowing to think about. If this is where we are now, what will quantum teleportation be capable of in 10 years, 50 years? It's exciting and a little bit unsettling at the same time.
I agree. As with any powerful technology, we need to think carefully about the ethical implications, and the potential risks. We need to make sure that quantum teleportation is used responsibly for the benefit of everyone.
Yeah, that's a really important point. It's incredible to think about how far we've come. We've gone from beam me up, Scotty, to thinking about the fate of the universe, all thanks to this crazy world of quantum teleportation.
It's been an amazing journey, and it's really just the beginning. Who knows what incredible discoveries and applications are still out there waiting for us?
I can't wait to find out. Thanks for joining us today for this deep dive into quantum teleportation. It's been a fascinating conversation. Until next time.